One of the four primary categories of building systems is services. While we easily see the enclosure, many services are often hidden from view. That said, they are a critical part of modern buildings and must be accounted for from the earliest stages of design. A network of pipes, wires, and ducts spreads out through most our buildings and are commonly hidden above ceilings and behind walls. Many modern buildings, however, do expose the service systems to view, making it easy to add, change, and maintain them. For example, this hallway in the most recent addition to Engineering 3, and looking up you can see numerous service distribution systems suspended from the ceiling. Notice the fire detector and fire suppression systems highlighted in this image, and also the insulated pipes that carry heated and chilled water, the painted EMT conduit distributing power and communications, and the duct for distributing both fresh air and heat and cooled air. The Davis Center exposes a lot of the service distribution to the public, part of its high-tech aesthetic philosophy. The green boxes here are electrical panels that contain circuit breakers and distribution, and the power wiring is contained in the shiny EMT conduit exiting the top. Looking up, the green boxes are called raceways and allow for easy changes to both power and communication wirings. This red box is a fire hose cabinet, of course, fed by bright red steel piping. The blue painted piping feeds a sprinkler fire suppression system, with some of the sprinklers heads will point upwards, as you can see here, and some of them end up pointing downwards. This design would be carefully thought out and specified by the fire services engineer responsible. The lighting system is also powered from the raceways, and as is usually the case, it is the lowest layer in the service systems. Mechanical systems are typically hidden behind locked doors in mechanical and electrical rooms, basements, or on roofs. In large buildings like E5 and DC, entire floors, often located at the top of the buildings, are reserved for large central equipment. Here we are entering the penthouse of E5. The red painted items you can see are the pumps that move hot and cold water around the building. Ahead of us, there's this large box which is called an air handler unit. Air handling units can be seen as a technical term for a fan in a box, but for large buildings, these fans needed are very large, and the air handling units contain air filters, heating coils, cooling coils, and humidifiers. Here you can see the entry of this air handler and all the filters that would be required. So this is an area that's about 3 meters tall and about 5 or 6 meters wide, and those are made up of individual filters, not very different than the filters you might have in a home furnace or air conditioning system. In other parts of this box, you're going to find that we actually have the means to provide heating and cooling and dehumidification. Here we're just going to take a quick look at the other side of the filters, so you can see the air leaving side. And here on the left you can see the heating coils, as they're called, or the place where the heat is provided to the air. That gauge there tells us how much air pressure is dropping across the filter, and when the pressure drop becomes large, it's an indicator to the maintenance staff that the filters have become clogged and they need to actually go and replace them. Now we're going to see here past these large insulated pipes that contain low pressure steam. We're going to have Stuart open the door here in this cooling coil section. On the left hand side you can see the coils, which are very finely divided fins of metal connected to pipes containing chilled water. We look here at these insulated pipes. That's where chilled water comes in to provide cooling, and there's a thermometer there so that service staff can check. And now we're going to go into this box opening called the humidifier. Again, on the right hand side we'll have the cooling coils where the air came from, and you can see a bit better with the light on. And on the left hand side we have the humidification section where we might want to add humidity during the winter time. So this box side with the doors labeled supply fan, this is the thing that sucks air out of the building, pulls it all the way through the air handler unit and delivers it to the building again. We're not going to open the door because the pressure is too high and it will be actually difficult. We'd have to stop the fan. But those boxes there deserve mention. They're labeled VFD, Variable Frequency Drive. This is basically a way of saying a variable speed, and modern buildings often have fans that can have adjustable speeds, which is great for efficiency and comfort, commonly seen nowadays. It probably won't surprise you that power, electrical power in buildings is really important. And over the years, more and more of it was used, and it's likely to be continuing to go up as a larger share of what's needed in our buildings. So the power that comes into a large building, this is for the Davis Center, the main feed into Davis Center, is actually quite large. It's like a small town. The cables are the thickness of my arm, and they need a bunch of connections, measuring, and shut-off abilities. And so here is the one wall panel that's basically just taking the power in from the utility, and then it's distributed. And to be able to even access some of these switches, they will often put keys in to prevent anyone from A, hurting themselves, or B, turning the power off to the building because it's just too important, including all of the electrical that runs emergency exit lighting, fire alarm systems, and so on. So here we are almost always dealing with three-phase power at this level, and these are 14,000 or 13,000 some volts. So very high voltage, very high power levels coming in here. And then it is spread into different circuits, and then the circuits are distributed through the building, and then it is broken down in circuit breaker panels into individual circuits like you'd know in a house. Now the main entry for the building is right here, and this is the shutoffs, and you can see the size of that handle and the fact that it takes multiple keys to be able to turn these on or turn these off. And that handle requires an awful lot of force to slam the contacts together, so there's actually a hydraulic pump inside. Large campuses of buildings often share services with a central services complex, like at the University of Waterloo or Kitchener-Waterloo Hospital. They share these services in tunnels that run below the streets and between buildings. And here's some images of what the tunnels look like at the University of Waterloo. Most students will never get a chance to go down there, but they do connect many of the older buildings together, at least within the rim road. And they contain mostly pipes for heating and cooling water, but they also are used for some power distribution between buildings. You'll notice in the upper left corner here that there are these bright red cables, and this contains some very high voltage, high power lines that are being distributed between buildings. So in these tunnels, it's more than just pipes that are highly insulated, moving heat energy around. So I really hope that you've got a sense of the complexity and the multifaceted nature of building services. There are the distribution side, and then there's the central building side. There are everything from pumping water, moving air, using electronic communications to run fire alarm systems and building controls, etc. So it's a very large and complex area that has lots of reason to have engineers involved coordinating and overseeing the work.